Hi, Prem. Can you hear me okay? Check, check. Hopefully the audio is all good. Let's check in the chat box. Hi, can you hear me okay? All right. I'm going to assume it's working. Looks like we only have Prem here at the moment, so a private session for now. As always, I have various tips and tricks that I can share with you if there are no questions on this week's material or the previous stuff or any effects things in general. A few people in their homework assignments were asking about things that you can do to make this a little bit less heavy to fracture, because this is a pretty heavy fracture that we're running on this geometry. So I'm going to go over this option that I've used a number of times in production to fracture each piece as a per frame fracture. So if we have 100 pieces in our interior here, we can run those on frames 0 through 99, where each frame represents one piece of our geometry, and just do a cutter generation and fracture for each piece that way, and then merge them all together afterwards. So I'll show that. Also, I got an email from one of the students to check why their prep was not working correctly, so we'll probably go over that as well. And hopefully you can learn something from the debugging of this problem yourself, even if yours was working perfectly. First, let's go over this per frame fracture. So let's see how many pieces we have in our interior section. The interior is the heaviest part of the fracture because, as I mentioned in the videos, it fills up the most 3D space, and our cutters are the heaviest, and there's just a whole lot of geometry on those interior sections. So if you middle mouse on your exploded view or the split for the interior, you can see we have 429 pieces. Now, if we want to run a fracture on each of those individually, it can be really helpful to pack up our geometry to help determine, or to make it easier to query how many different pieces they are and to isolate them. So if I pack up this geometry, we'll turn on the pack by name option and display that. And you can see we have 429 pieces, which will match the number of distinct name attributes in our geometry. And I'll just create a null under this, and I'll just call this frac pieces for fracture pieces. And we're going to isolate just one piece per frame. So to isolate just a piece at a time, I'll drop in a blast. And in this blast, you can just use an integer number to define a primitive. So if we just put 1 in here and delete non-selected, we should see, yep, just one piece at the top. If you check piece 100, that'll give you a different one, and so on. So instead of just defining the number by hand here, we'll use the frame variable. So make sure to put the frame and backticks. If you don't wrap this up in these backticks, it won't work. It just won't, it won't evaluate this properly. You can see right now we're getting nothing. Well, first, we're on frame 1034, and we only have 429 pieces. So we'd expect that even if we typed this incorrectly, that wouldn't give us anything on this frame. Let's go to a valid frame instead, like frame 300. But we're still not getting anything until we add those backticks in there. I know it sounds like I'm really repeating myself a lot, but it's important to get used to some of these weird syntax things that you might not be familiar with. Now, when we're isolating one piece per frame, And actually, I'm going to change my timeline here just to make this a little bit easier to step through. I'll change the start to 0. So you can see as we change frames, it'll jump to different pieces. And now we could do a cutter generation for each piece individually. So I'll drop in my cutter generator here. And when we're running on each piece individually, well, first of all, this is giving us nothing because we need to unpack our geometry. At least I'm assuming that's what's causing that problem. Is it? Let's see, where is that geometry? Okay. Maybe this is a result of just the crazy values in the defaults for our cutter geometry. I should really change the defaults for this because unless you're working at a large scale, these defaults are a little bit silly. So I'll just start by turning the noise amplitudes all the way down. We could actually, let's just copy our values that we set up on our other cutter generator because these are world space values. So the noise that you set up when you're, let's see, okay, there we go. Sorry, I have my view set to manual so it wasn't updating. If you already set up a cutter generator for this entire interior section, then all of those noise values should work well for the small piece as well. So we could just copy that whole thing. I'll disconnect it, delete this cutter generator there, and we'll wire in our piece to that. Although for the entire interior section, we were using, at least I used 65 cutters. For just one piece at a time, we don't need nearly that many. Maybe 5 cutters would be just fine. Let's template view our piece. So you can see we've got 5 cutters here. This actually looks like it might be a little bit too jagged for my taste. Yeah, it looks a bit too extreme. This is what I ran in my shot, but I'm not sure if this cutter is much higher res. Oh, I see what the problem is. So although the noise settings should work when you copy it like this, this is going to be a lot higher res than it was on our cutter geometry generation for the whole interior. Because one of these settings defines the resolution for each cutter that's run through the surface. And if you have 300 divisions for your initial resolution, when you run that on one tiny piece, it's going to be using 300 divisions just for this one little piece of geometry, which is totally unnecessary. So in this case, we just maybe need to use like something much smaller. We'll try 20 divisions. That's probably more than enough for this. Let's turn up our padding multiplier. I'll set this, you can just put just a multiplier in front of that expression. So I'll say 2 times whatever that is. Maybe turn off the trim option. There we go. Looks like we can leave the padding multiplier alone actually and just turn off the trim. Or you could turn the trim back on, but this looks like we just need to expand that a little bit. Or a lot. There we go. Looks like a trim of 10 is pretty safe in this case. A lot of these settings, and just with effects work in general, there's a lot of settings that are very delicate between different scene scales, which can make it hard to copy setups between different shots that are, you know, at drastically different scales, because so many things are size dependent. And this does still look a bit too noisy for me. I'll try turning, well, let's try skipping that mountain to begin with. Maybe I'll turn off some of these mesh subdivisions, reduce that to 2, and the small noise amplitude. I don't want to get too picky about designing these cuts right now. This will be good enough. This will also vary some per piece as well. And whenever we're cutting up our geometry in a loop or frame by frame like this, we want to make sure that we give ourselves extra buffer just in case for some reason the noise on some piece of geometry pushes the cutter into the geometry or something like that. We want to avoid any problematic cutter intersections. So always give yourself a bit of extra buffer. Maybe I'll turn this up to 30. I'll leave that mounted on there. And now that we have this set up, we can do our normal shatter on this. So I'll hook that unpack up to the first input of the shatter, and then the cutters into the second. And you can see, because this is a very simple process, that shatters pretty much instantly. We can run the exploded view to see what that looks like. And this looks like a pretty good level of detail for this shot. And now we can run this fracture per frame. And this is so fast that you could actually just jump between frames here and see what the result looks like for some different pieces. And this is all pretty fast. So once you have this set up, you can use a file cache to run that on all of the frames that you need. And we'll hook that up to our shatter output. And this is another example of where the RBD pack is extremely useful. So we want to save out the constraints along with the geometry. So if we drop a null here, we can check out the constraints associated with this fracture. And as I mentioned in the videos, you don't want to just merge those together. We have to use the RBD pack to preserve the data nicely on each of those. So we'll connect the fracture to the first input and the constraints to the second. And if you want to, you could actually do a convex decompose during this process as well. I prefer to run a convex decompose after I've cached out the fracture, just so that if I want to change the decompose settings, I don't have to rerun the fracture as well. But you could theoretically, add the convex decompose at this stage if you really wanted to. So just to demo what that would look like, if this is our fracture, our convex decompose would look like this. Let's see that exploded. So that's the convex decompose for that high res. So you could potentially put your decompose into that RBD pack as well and generate this all in one pass. I'll skip that for now though. And on this file cache, we want to keep things as procedural as possible. Now there are 429 pieces that we're running this on. So you want this to run from frames 0 through 428. Now you could just manually enter that in your file cache settings here, but I prefer to use endpoints lookup to determine this procedurally. So let's say we change our interior geometry or something. For example, maybe you said, I want to, I don't know, like expand the area that the monster is affecting, or I don't know, chop this into some additional separate floor tiles or something. I don't know. Anything like that. You never know when you're going to want to make upstream changes. So avoiding these hard-coded values is always good. So you can use an endpoints lookup, and we're going to point that to frac pieces. That's that null just above. And if you just use the endpoints expression directly, this will give you a value of 429, because that's looking up the number of points in this null here. But since we're starting our numbering at 0, you just want to subtract 1 from that value. So endpoints of frac pieces minus 1 will give you a value of 428. Now, I'm just going to maybe run half of these, or even less than half for the sake of the demo. I don't want to wait too long for this to process. So maybe I'll try just saying 0.2 times that. I'm not sure what this would do with decimal values. For the sake of this demo, I'm just not going to use the endpoints expression. I'll just run this on 20 pieces, just so you can see what that looks like when we merge it together. So always turn on load from disk, and let's point this to our caches directory. I'll just make a test folder and call this per frame fracture. And you want to make sure that your fracture file name has a frame number in it. If you just keep writing this to perframefracture.bgo, it'll keep overwriting this same bgo file, and you won't be able to merge the results after. So definitely include dot frame or dot frame with a padding of 4 is what I usually use. And I think we're all good to run this. Let's call this, I'll call this distributed fracture, because one way that I often use this is with a render farm. So at work, we have lots of machines available on the farm to do caching for us. So if I run it like this, then it'll do a different frame on a different farm processor. Or it could be chunked together in groups of 10. So maybe one machine will do frames 0 through 10, the next will do 11 through 20, and so on. But just running on my machine here, I'm not using a farm, I'll just save this to disk. It should be pretty quick to fracture those 20 sections of our geometry. It's not too bad. This really avoids the problem of needing to generate super heavy cutters. So almost done. Let's see what this looks like. Now, if you view this file cache, it's just going to try to pull in the file for the frame that we're currently at, which is 295. We haven't cached a frame 295, so we just want to merge this. There are a couple ways of merging the results together. You could use I forget the name of it, because we have our own caching tools at work. Here's file merge, that's it. I don't really use this at work because we use custom things for our caching, but we can copy this file reference from our file cache. So do a copy parameter on the geometry file. You can paste that into the file merge. So paste the relative reference. See what that looks like. And for this merge variable, we'll see if this works to just use F4. I don't know if it will respect that. I'll put in a cache length of 20. Actually, we'll use this merge range, so that'll be from 0 to 20 with an increment of 1. See if that works. I guess it doesn't like that. I'll just copy the string directly and paste that in here. And instead of $F4, we'll type in $slice, which is the default merge variable that this uses. Am I doing something wrong here? This says, oh, I see what the problem is. So I'm actually glad we ran into this problem, because when I run into these problems, you can see what the debugging process looks like. So if you middle mouse on this file merge, you can say it's unable to read the file because we wrote out our files with padding on it. So for frame 2, this would write out a frame 0002, but the file merge isn't doing that. I'm assuming Don't know if we have any padding options in here. Sometimes in these situations, you have to use some complicated expressions to control the padding in here, which we could take a look at. I have to hunt through the docs to see what those padding expression options are, just to give you an idea. And it's different in every programming language. In some cases, there's a pad 0 function. Looks like, and whenever you look up functions in the help docs, it tells you whether that's an expression function or a vex. So you can see here it says pad 0 is an expression function. If you type in something like rel bbox, then this tells you this is a vex function. So the difference there is that vex functions you can use in contexts like a wrangle node. You're using raw vex in here. There's some other places that you would use vex as well. Expression functions are used in any Houdini parameters like this. So I shouldn't have closed that. Rather than just making it easy on ourselves by recaching this without padding, I'll try actually fixing that padding here. Oh, it looks like we have a bunch of more people in the session now. I didn't notice everyone else join. I mentioned this in the previous session, but anytime you have questions in the live Q&A, feel free to just fire them off in the chat. You don't have to wait for me to finish talking or anything, and I'll keep checking back in the chat window to see if any questions have popped up. Hope everyone can hear me. I'm assuming I'd hear complaints otherwise. Can everyone hear me okay? I just like to get, okay, cool. I always just like to get confirmation because every once in a while, if I forget to turn on my audio mixer software or something, it won't work. And we don't want a silent demo in the recording. Okay, so yeah, back to this padding thing. I know this sort of stuff is not probably the most exciting part of destruction process, but all right, this pad 0 function will return a string representation of your number with the number of digits specified by that first argument. So in this case, we should be able to use the variable slice in this value here and tell it to pad it to 4. Hopefully I can get the syntax right because I don't have to mess with this very often. So I'll put this in backticks, this pad 0, and I'll pad it with a size of 4. We'll use that slice variable and see if that works. Okay, cool. Looks like that did the trick. I'll copy paste this into the chat window in case that's hard to see. Also, whenever you're working in parameters, especially if you start running lots of long expressions, it can be really hard to see. So you can just click in there and hit Alt-E to bring up the string editor instead. And sometimes that's easier than working in here. So yeah, if you middle mouse click on this, you can see what it, actually, it's not showing what that evaluates to. Maybe because it's doing something clever with this slice, I don't know. Usually, I'm surprised that's not showing us the actual numbers. But in any case, it does look like it's working and correctly accumulating all of those pieces. So let's zoom in on that result. Check out the results in an exploded view. Oh, actually, we can't do an exploded view straight away because we did the RBD pack on this. So right now you can see, yeah, we don't have access to all the pieces directly until we do an RBD unpack. And we'll do an exploded view on that. And this is what our per frame fracture looks like for those pieces. So yeah, hopefully this will help out some of you that have a render farm at your disposal, or if you're running into problematic fractures. The other thing that this is really helpful with is finding out which piece is erroring out in the fracture. So if we have more than 400 pieces here and we fracture them in one pass, if you were to have certain pieces not fracturing correctly, it might be hard to diagnose which pieces are problematic. So if you do it this way, you could tag the end result with which frame that is, which primitive number, and you can also just go through the frames to find the problem piece, and then you know exactly which one you need to deal with separately. And that could just help the debugging process to have all of your fractures in separate frames like that. Taylor had a question. I was wondering if you normally use HTAs just to make personal workflows more efficient, or if you'll pass them out to your team as a standard for a project, so everyone is using similar process on a look dev standpoint. It's a good question. It's a very, very valuable skill to have in a production environment to be able to make useful tools like this. And pretty much everywhere I've worked, they highly encourage people to create and share HDAs. Sometimes people just have their own personal libraries of them. Sometimes these tools might just exist for a show. Sometimes they'll be added to General Studio toolset. But yeah, it's certainly very helpful, especially when working on a production where you're repeating similar effects. So I've worked, especially in destruction heavy shows, you often destroy a lot of the same things. So I've made my own window fracture HDAs so that all of the windows throughout a certain sequence will be fractured in the same way. Because if you have 10 artists working on a shot, and if they're all running their own independent window fractures, they could all look drastically different. So creating an HDA so everyone is using essentially the same setup or even the same exact settings can be extremely useful. From an efficiency standpoint, but also artistically for consistency across a sequence. All right, any other questions in there? Not yet. If there aren't any other questions here, then maybe I'll take a quick peek at Peter's scene to see what might be going wrong in here. When I opened his scene, I didn't add his HDAs to my Houdini path. So that is throwing some errors. I don't think it's a problem for looking at his scene because I don't think those HDAs are used at this point. Maybe his shatter HDA is. Actually, let's... yep, this is using his shatter HDA, so I'd have to use that in order to debug the scene. But whenever you're sending scenes for debugging, it can be really helpful if you right-click on it and allow editing of contents, and then save the scene that way so that it doesn't rely on the HDA. I can, copy custom HDAs into my search path, but it can be a bit of extra work to keep track of that stuff. Let's see. I'm sure there are ways to hot link. No, it's quite all right, Peter. No worries. Not your fault. It's good for me to highlight these things for all of the other students as well. Under assets, you can go to install asset library here. And also, just to clarify, it's not a problem to send scenes that use custom HDAs. Sometimes it might be a bit complicated to find all the relevant HDAs and unlock them. I know that can be a pain, so it's workable to send your HDAs as well. So if you go to assets and install asset library, I think we can probably grab the HDA this way. Let's go to this STN shader and select that. And this gives us options to install that library to the current HIP file only. So I'll leave it with that selected. See if we need to worry about these advanced options. I don't have to do this sort of thing very often, but in this case, it's quite helpful. Yeah, that'll work fine. You can just install it and it should fix all of the missing references. If you hit install and create, that'll also just create a new geometry node and drop in a copy of that in your scene, which is probably kind of unnecessary, but it's an option if you want it. But yeah, now that we've installed that HDA, it looks like it is finding the definition. Yeah, the only thing this is complaining about is just because his alembics are in different places. Another helpful thing when you're sending files can be to lock your geometry at a certain point. For the prep of the building, it's not as much of a problem because we're grabbing things directly from the alembic. But in cases where maybe we're debugging a problem with the sim, you could lock your simulation geometry into the scene before sending the HIP. And that only works on single frame caches, not animated things. But that can be a lot easier than trying to send caches along with your scene. Let me just fix this alembic location. Let's go to my transfer. Okay. Now let's see what, I think we've got enough fixed here that we can figure out what might be going wrong in the scene. So I believe Peter was saying that his isolated shadow region wasn't getting separated properly. So let's double check the output of the shader, see what's going on here.
Hey Keith, are you able to hear me?
Looks like everything is being shattered correctly. And the area measure looks all right at a glance. This all looks good so far. Sorry if this is not the most exciting debug example. This sort of stuff is always, some of the most valuable stuff, I think, because when everything works great, that's awesome, but things never work perfectly. So seeing all the various problems that can arise is very helpful. All right, so the split looks like that's working properly. At area A and area B. At a glance, this looks all right. So this could potentially just be a problem with the split. Hopefully that's the case because that's often the easier problem to figure out. If you bring up the spreadsheet, let's check the fracture values. Oh, in the split, there's actually nothing defined in that group there. So looks like we just have to, I forget how I set this up. I do these things different every time. So it should just be the fracture attribute equal to 1, if I remember correctly. Okay. Is this, yeah, I'm trying to figure out if it's just a matter of not including all the, oh, it's just the window frames. I remember that. Okay, that's what the problem was. What did I do here? If you put in the fracture attribute, the frames don't get included. Yeah, maybe I'll take this one offline and not debug it live. Well, if there are any other questions, then shout them out because I'll prioritize any of those. It'll take another minute to figure out what's going on here, but sometimes it can take a little bit of poking around to figure out what's going on. I don't want to, make everybody watch too much poking around. Just wanted to see if there were some obvious problems that jumped out straight away. We can also just isolate the problematic area to make this a little bit easier to view. So in this case, it's just the window frames that are not being isolated correctly. So I'll just hook up the window frames to this measure output. And we'll take a look at this. All right, so this for each loop is running. I see what's going on. It looks like the window frames don't have unique names. So if we check the name attribute here, there we go. They're all called window frame 0. So, and I'm glad we actually figured it out and we didn't have to call it a failure. So when we're iterating on the names here, each window frame, in order to be split out into the two groups correctly, would have to have a different name. So let's just fix those names here. There is a class attribute, but I'll just to make sure we have good class values, I'll use a new connectivity SOP. And the existing one is on points, and point class can be fine. And this might actually be the problem you're running into. I see what's going on. Yep, so this is the real problem here. You're setting the names correctly after fixing the windows, but this is a primitive name, and any attributes that you're querying in here just by the attribute name they have to be primitive attributes as well. You can look up matching point attributes. You could do something like look up the point attribute from input 0, and we'll look up the class, and we'll grab that value from, actually this only works with packed objects. We'd have to find the corresponding point to match the primitive, and that just turns into a real mess. But the whole problem will go away if on this connectivity SOP here, just change that from point to primitive. Now all of these names are unique. I'll set that spreadsheet to always on top. So now you can see unique names, non-unique names. Because this class attribute doesn't exist on prims, it's actually creating it. When you query it, it says this doesn't exist, so I'll just create it with a default value for integers that'll be 0, which is why they're all called window frame 0. You can also middle mouse on here to determine the number of unique names. That's another helpful check. With that connectivity turned off or set to points, you can middle mouse, see there's only one unique name. It's just another way to help debug the problem. So with that fixed, let's try running this whole thing together again. We'll just recombine that with the geometry. Looks like, yeah, it's rerunning our shader because our input upstream changed. Just while I'm verifying that this fixed the problem, does anybody else have questions in the chat? Anything else? Nope. And hopefully we're all good now. Let's turn off the template view. All right. Looks like that fixed the problem. I'm glad we were able to sort that out. All right, so another thing I'd like to comment on is a little bit difficult to demo because it's in regards to Boolean fractures that error out. So we have lots of windows here, and in this scene, whenever I'm working on large-scale buildings like this, I often don't do a real fracture on all of the windows. Like you'll see once we start going over the window simulations, I tend to emit RBDs and particles. Just a true emission, not based on individually fracturing them. But in cases where I do want to see lots of glass cracking, I will often fracture that in a loop. And whenever you're fracturing tons and tons of pieces in a for each loop, or using that per frame thing that we just went over at the beginning of the session, you could occasionally run into a Boolean fracture that errors out. Now let's say you were running it on all of these glass panes. Let's say for a fracture on this pane here. Let's turn down that pen size. And we have cutters running through it like so, maybe a bunch of radial ones, etc. Sometimes when these Boolean fractures error out, you'll see all of this cutter geometry included as part of your final fractured output. It looks totally broken and almost like a copy of the cutters are just merged with the geometry. And in this case, it's something that can just happen once in a while. The Boolean process is quite good. It generally works well if your geometry is clean. Always make sure you have no unshared edges in your geometry, or sorry about the doorbell. And always make sure that the normals are consistent and pointing the right direction. But even still, with all of that correct, you can still run into errored out fractures once in a while. And the kind of hack fix that I've been implementing lately is to check the bounding box after the fracture. So if I drop in a for each named primitive, we'll pretend this is our fracture loop. And if we run the fracture, I'll just drop in a fake subnetwork to kind of outline what this would look like. Let's say we have a glass fracture subnet. Then I can use a switch node to detect the size of the bounding box. So in the switch, I might say the B box lookup based on the original input, and we can set that up as a spare input. So go to the gear on your switch here and add spare input. We'll drag the for each begin into that spare input there. And you can say the B box of input -1, which is that spare input number, and look up, that would be D underscore Y size. And this is giving us warnings because this isn't a real example. You could say if that's more than, we want the original Y size. Sorry, we want to also look up the Y bounding box size of our glass fracture output, which will just be input 0 of the switch. So we'll say if the Y size of input 0, that's this glass fracture, is greater than, I'll say 1.3 times the bounding box size of our original geometry. So if this is 30% taller than our original, then we know this has errored out. And oftentimes when this happens in a fracture, is assuming your input is good. If you just put the tiniest little offset on your cutters or on your actual geometry, it can totally fix the problem and make it run just fine. So if the switch detects the problem, this conditional statement, which I'll copy and paste into the chat, that will evaluate to true, if all these cutters are included in that output. And then in that case, I might just do a slight transform on the geometry. It can be just the slightest offset. I'll do maybe 0.1, and I'll right-click on this transform, create a reference copy. And if we scroll down in these transform options, there's this option for invert transformation. I'll Control-Shift-click that to get rid of that link to the original transform and turn that on. And I'll take another copy of that glass fracture subnet, and we'll put that between those transforms. And so, and of course, this is all erroring out because, we're not actually running the fracture. And like I said, it's hard to really demo this without a scene that's breaking in this way. But what this will do is, if it detects, that the fractured size is being that much taller, it'll run this other version instead. And that this problem is rare enough that just running it a second time is likely okay. I've just done this in a scene very recently that I've been working on, and you could even run this a third time. I'll hook up input 0 to that switch, and then I'll copy this whole thing and give ourselves a third fallback if even the second one is problematic. So we can do this sort of thing, and this gives us 3 chances at the fracture working correctly. And if the third one doesn't work correctly, then it's tough luck. That will just export that. And this is not the most elegant solution. It's a bit hacky. I'm sure there's probably a way of detecting it, without doing it in a switch, doing some sort of loop in here to figure out if the Boolean output is okay. If it's not, then rerun an iteration of the loop. I haven't figured out how to get that working yet, but as a quick fix, usually 3 tries is plenty to make sure that those random errors don't happen. And yeah, although it's pretty hacky, it's been quite helpful in a setup I've been working on recently. So hopefully that makes sense. If any of that's confusing, just let me know and I will try to clarify. It's like we still have, almost 10 minutes here. So let's see, what other little tricks can I show you? Looks like no other questions in here. I don't think we have enough time for me to show the target velocity trick that I use to make objects feel heavier when I can't just adjust gravity. But I suppose I did mention it in the video, so I don't want to be too redundant with the live info. Let's go back to my notes here. This rotation for clustered pieces is really helpful, but I want to wait until we talk about constraints to go over that. Let's see, what else? I suppose we can briefly talk about, no, that's probably better for week 5. Let's see, anything else? No more questions? I think we might wrap it a little bit early if there aren't any, since we're only a few minutes short. And anything else I'd get into right now will probably take more than that few minutes. Take a look back at the scene to see if anything else jumps out as a helpful technique. Actually, I'll show you one thing. For some wood splinter fractures that are not perfect shaped boards, this could be a quick little tip. Let's create a rough approximation. I don't know why my tab's not working all the time. There we go. I'm curious if other people are running into that problem with the tab menu occasionally not working for a moment, or if it's just because I'm running screen recording software at the same time. I'm not sure. So let's change our tube to be polygons. And the orientation I'll set to X. And I just want to make something that's more like a log instead of just a board. Let's set the height to, I guess, 10. Let's give this a lot more divisions. Let's do 20 by 40. And I'll put a little bit of mountain noise on this. This is just going to be a pretty rough approximation of a log. It's not going to be the most beautiful log model. Let's go bigger with the element size for this. I just want some kind of soft shape offsets. So something like that. Taylor said he's been running into the same tab menu thing as well, but only when something else is running. Yeah, glad it's not just me. On this tube, let's turn on end caps as well. I thought there was an option to add resolution to those end caps, but not seeing it, so I'll just drop in a divide. All right. So just another small thing on this divide node. Sometimes if you turn on avoid small angles, you can get some better distribution of divisions. It's kind of up to you what works best. So with this sort of thing, I've had this plan recently where if we were to just do a shrink on this, then our Voronoi splinters would be, perfectly straight. And it would be pretty cool if instead of being perfectly straight, they kind of flowed through the branch like that. So I've had this plan to take some sort of an approximation of that shape. So if we take our tube before the mountain, and I don't know what the best way is to do this. If you want to hand place the tube, or it looks like instead of hand placing it, it looks like instead of just copying our original tube, if we create a new one and pipe our branch geometry into that, it looks like it creates a bounding tube pretty nicely. This is actually, I'm glad this works as well as it does. I was afraid that you'd have to kind of manually line up some sort of approximation tube. But in this case, we're going to do a ray on the geometry. And this is going to be very similar to our other pre and post deformation techniques. So let's see if this is raying properly. Let's just, instead of doing project rays, I'll try a minimum distance. Looks like that works pretty well to ray our branch to the edges of this tube. And before we do that, I'll add some rest data here. And then I'll apply this ray. And now I'm going to, actually maybe I'll use the pyro source to scatter points inside. Typically we've been using VDB from polygons to generate a fog VDB of our object, and then scattering points in that. But you could, for your Voronoi processes, it sounds kind of silly, but this pyro source just creates points for you. And you can select between surface points and points within the volume. Where is that? You can say volume scatter instead of surface scatter. Although this isn't as random as a regular scatter unless you jitter it. So I'm just going to put a point jitter on this instead. It's just interesting to see some of the other options that you have at your disposal. So after we have our Voronoi points, we'll run a basic Voronoi fracture on this and see what that looks like. We're up against the clock, rapidly running out of time. Let's see if I can finish this first. Actually, so we want to, in order for this to be a proper wood splinter, we want to do our classic transform down before we do this. So let's drop in our transform. Looks like I still haven't saved my centroid preset, but in this case, probably doesn't matter. Oops. Because I think this is centered around 0 anyway, at least in X. All right, let's see what this looks like. And I'll copy that transform node, create a reference copy, put it after the Voronoi, Control-Shift-Click to disconnect invert transformations and turn it on. And let's check the exploded view on that. Cool, so we have some splinters here. And let's see if this works to just set this back to its rest position. So in a wrangle, let's go to a point wrangle. I'll say at P equals at rest. See if that does the trick. All right, that kind of does it. But in order for this to work, we'll need some more resolution on the inside faces. So let's see, do we have to divide that? I know we have our RBD interior detail. I don't really want to use any noise, but I guess we could use our RBD interior detail just to add some resolution to those inside faces. So I'll check the exploded view on this. And this is adding some resolution in there for us. Let's try adding that to the wrangle. All right, looks like no love here. We'll have to see, because this is, for all these inside faces, it looks like it's not interpolating that rest data nicely, but we can use another little trick to get this to work. At least I think this will work okay. I'm going to use a point deform, and let's point deform. I'll keep this version of the fracture that has the interior detail, point deform that fractured mesh, and the rest position will be this rayed version of our branch. So this is our regular branch geometry rayed out to that tube. That'll be the rest position. The new position will be the branch geometry before we've rayed it out. So that kind of works. That looks like maybe it's just the normals that are wrong, so I'll create some new normals on the geometry. So that's it looks a bit broken. Sometimes when you run into problems like this, you might just need to add some more resolution to avoid some issues with the normals. And this is kind of an experimental thing I've just been thinking about recently. But if we do an exploded view on that, it's actually looking pretty cool and pretty promising. We'll have to take a look at the normals to see if that's problematic in render. But when we do this fracture on the even-shaped tube, and then kind of squish it back down to match the original model, it looks like, yeah, looks like we have this nice wood grain that kind of flows along that deforming geometry. So yeah, don't be afraid to experiment with different fracture techniques like this. You'll run into unique situations sometimes that require a little bit of creative problem solving and coming up with some fresh approaches for things that you might not have done before. So glad that kind of worked out. So yeah, as usual, if anyone has any questions or problems with this week's material, post in the forums or shoot me a private email if you'd prefer. And yeah, this week we're going to be running those RBD sims, and I'll look forward to seeing what everyone's simulation of the full building looks like. Talk to you soon, guys. Good luck.